Hello everyone, this is Irfan Bhomik. In this video, we will be discussing about the architecture of an Arduino board. So let's get started. There are mainly three things in the Arduino environment: the Arduino board, the IDE that is used for programming, and the shields. So the Arduino board is the one that we're gonna discuss in this video. The IDE is the integrated development environment, which is simply a software that is used to program our Arduino boards. It can be downloaded for free from the official website of Arduino. The shields are add-on hardwares that can be stacked directly on the top of our Arduino boards and can be used with different libraries. Here comes the hero of this video, one of the most popular development board, the Arduino Uno. Let us now see in detail what are the things present inside this board. At first, we have a small red button on our board known as reset button. This button is mostly used when we have to restart the Arduino code from the beginning. Then we have an USB connector. This is used to connect the board with our laptop or PC so that we can load our Arduino code from our system to this board. We don't need any external power while using USB connector because USB can also provide the power. But it is quite obvious that we won't be powering our Arduino board using the USB connector and our laptop. So there is a dedicated DC power jack given on this board which is used to power our Arduino board. It can receive any voltage between 7 volt to 12 volt. But our Arduino board operates at 5 volt DC. Thus, this board also contains a voltage regulator that reduces the input power through the DC power jack to the 5 volt DC level that the Arduino uses. There is another way of powering our Arduino board, that is using the pin named as VIN. Arduino contains 14 digital input-output pins. Voltages can be either 0 volt or 5 volt at these pins. At the same time, Arduino also contains 6 analog input pins. Voltages can be anything in between 0 volt to 5 volt at these analog pins. Remember, Arduino have ADC, analog to digital converter. Thus it can only accept analog inputs, but it does not have output analog pins due to the lack of DAC, that is digital to analog converter. So basically, using the 14 digital input output pins and 6 analog input pins, Arduino can communicate with the outside world. I have an Arduino board here. This is an Arduino Uno. This is the USB connector. I have a connector here too. This end gets connected with this Arduino board, and this terminal gets connected to your laptop or PC. So using these pins, here are 14 digital input output pins and the analog pins over here and the power pins over here. So using these pins, Arduino can communicate with the outside world. How it can communicate? It can sense the environment using plenty of sensors available in the market. I have one of them, that is this one. You can see this is an IR sensor. It contains 3 pins. One is VCC, one is ground, another one is for signal. It senses when some object comes in front of it. So using this sensor, it can sense, the Arduino can sense whether something is coming towards this sensor or not. Fine. So similarly, there are plenty of actuators or reactors available in the market. Some of the examples are the motors, LEDs, and there are a lot more. So using these sensors and actuators, Arduino can communicate with the outside world. Arduino provides 14 digital pins. Among those, the first two of them are used for serial communication. That is, for example, if you want to build a smart system, for example, we have developed a mobile application using Bluetooth protocol, and we want to control our Arduino using Bluetooth. Okay, so we will be transmitting data using Bluetooth. and the Arduino will turn the switches of our home accordingly. Okay, so in that case we will be needing a module, a Bluetooth module, this one HC05, a Bluetooth module. It has a number of pins, 6 number of pins, and using this Bluetooth module we can communicate with Arduino using our mobile app. So there are two pins, also you can see here there are two pins, the RxD and TxD. RxD is used for receiving data. For example, if we transmit data from mobile app to, for example, to turn on the AC or turn on the fan or turn on the light, it will receive data through the RxD pin, and the TxD pin will be used to send data to the mobile phone. Now let us come to the main component of this board, the microcontrollers. Arduino Uno has two microcontrollers. Number one is Atmega 328, that is marked with yellow, the bigger chip, the main microcontroller that executes the program. And there is another microcontroller marked with red, that is Atmega 16U2. It handles the communication with the USB. USB is simply a protocol, and Atmega 16U2 just understands the USB protocol. Thus the data that comes in through the USB 16U2 translate into something that the 1328 microcontroller understand. Same thing happens during reverse process. When 328 wants to write or send something, 16U2 translate into USB protocol. Now this microcontrollers comes with preloaded firmware in it, which allows the flash and EEPROM to be programmed. It also manages USB communications since application program is done via USB. There are 6 dedicated pins for ICSP. It stands for In-Circuit Serial Programming. It is a special programming method to program the firmware. This is needed because the firmware, also known as the bootloader, cannot be reprogrammed itself. In Arduino Uno, there are two ICSP ports for two microcontrollers. These are called ICSP headers, each consisting of 6 dedicated pins. And finally, there is a 16 MHz crystal oscillator. None of the microcontroller in this world can work without oscillators. It provides the clock pulses to the microcontrollers. Now it's time to summarize. Arduino Uno board contains 8-bit microcontroller. It is operated with 5V DC supply. Recommended input voltage is 7V to 12V, although it has a limit up to 6V to 20V. It contains 14 digital input-output pins, of which 6 are provided with PWM, 6 analog input pins, flash memory of 32 kilobytes, of which only 0.5 kilobytes are used by the bootloader or the firmware, SRAM of 2 kilobytes, EEPROM of 1 kilobyte, and the required clock speed is 16 MHz. Thank you.